Hi and welcome to my walkthrough to practice set 4 paper 1 non-calculator paper from AQA. I'm just going to have a quick look at some of the more interesting questions today, some of the ones that I think are going to prove the most difficult. As with all the new GCSE papers, we're going to start off with some multiple choice questions. These are all normally worth 1 mark and should be pretty much instant recall. The first question is just looking for the highest common factor of 4x squared y and 8xy cubed. If you break this down into each individual variable, you can find this quite easily. So if we first look at the 4 and the 8, the highest common factor of 4 and 8 is 4. And then if you look at x squared and x, then you're going to get the highest common factor of that of x, and of y and y cubed. Well, the highest common factor there is y, so we're looking for an answer of the 4xy. The second part to the question is quite similar. You're just now looking for the lowest common multiple. So the lowest common multiple of 4 and 8 is 8. Of x squared and x, that would be x squared. And y cubed, you're looking for y cubed. So again, the answer's 8x squared y cubed. The next question is new to the GCSEs this year, and we're looking at values of sine, cos and tan. These again are expected to be instant recall, and you need to try and learn these before your exam. If you are struggling to remember these, a nice way to try and remember them is using a table. If we start with sine, we should know that sine 0 the graph starts at 0. It then goes up quite nicely. You get a half, root 2 over 2, root 3 over 2, and then for 90 degrees the sine graph peaks at 1. The cosine graph then is just the opposite, so it goes 0 at 90 degrees, a half at 60, root 2 over 2 at 45, root 3 over 2 at 30 degrees, and at 0 degrees it's 1, it takes a value of 1. So the value where it's both the same is 45 degrees. The last question then is looking at the gradient of a straight line. To do this, we need to try and put the graph into a usual format that we're used to looking at, which is y equals mx plus c, where the m is the gradient. So we're going to rearrange this formula so that it looks like y equals something x plus or minus something. So we're going to start off by 4y plus 3x, and I'm going to move the minus 1 to the other side, so that becomes a plus 1. I'm now going to move the 3x, so we're going to take away 3x from both sides. So we get 4y equals minus 3x plus 1. And then because we've got 4y and we're only wanting y, remember, we need to divide by 4. So we're going to get y equals minus 3 over 4x plus 1 over 4. This bit here, remember, is our gradient. So we've got a gradient on this graph of minus 3 over 4. Question 4 of this paper is showing something that's quite common throughout the new paper sets that AQA have released, and that's where it's combining topics together. So here we're looking at the area of a circle, and we're also looking at ratio as well. So we're going to start off by finding the area of the whole circle. It tells us that the radius of the circle is 6 centimetres. That means that to find the area of a circle we're going to use the pi r squared, which means in this case we've got pi times 36, or just 36 pi. Looking at the next part of the question, we are just wanting the area of sector A. Now it does tell us in the ratio that there's the area of sector A to the area of sector B is 1 to 3. So I'm just going to sort of highlight what I'm looking at here. So really we're only looking at half of the circle. Now because we know the area of the full circle, we can just half that. So that means the area of the half circle at the top is just 18 pi. Now using the ratio, we can see that because it's in the ratio of 1 to 3, we can write that as 1 to 3 for sector A to B. Okay, now here we've got 4 parts in total. We need it to be 18 pi parts, so here we've got 18 pi. To do this, we've multiplied 4 by 4.5 pi. Now we therefore want part A, so we're going to do the same here and multiply that by 4.5 pi, meaning that sector A is 4.5 pi centimetres. We can go ahead and write that on the line at the bottom. Question 8 is having a look at solving inequalities. Now we can treat these very much like solving any normal equation. They've just got an inequality sign in there. So if we look at the first one, 2x plus 7 is less than 0. That means that 2x is less than minus 7, which means that x must be less than minus 3.5. It also tells you in the question that x is greater than minus 10, so therefore x is in between minus 3.5 and minus 10. Now it's telling you to list the integers that satisfy both these inequalities. Now integers is just a fancy word for whole numbers. So if we're looking for less than minus 3.5, the next integer there is minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, and it needs to be greater than minus 10, so we can't include that. Question 9 is just a directly proportional question, and when we're looking at these type of questions we are going to be using y equals kx, so we need to find out what k is. So in the question it tells us that y is 63, we don't know k, and that x is 7, so we're multiplying by 7. So to find out k we need to do k equals 63 divided by 7, which is 9. We can then find the other two blank parts in the table quite easily. We just need to multiply x by our value of k, so we're just multiplying it by 9. So minus 8 times by 9 is minus 72, and 0 times by 9 is 0. Question 10 is just checking your understanding of quadratic graphs. It's first telling you to complete a table. So for each of these we're just going to sub in the values of x into the equation that we're given so that we can find out y. So we're going to start off minus 1 squared, so minus 1 times by minus 1 is 1, and then we're going to be taking away 2 times by minus 1, so we're going to be taking away minus 2. So therefore we've got 1 minus minus 2, or 1 take away minus 2, which is 3. For the other two tables we're going to do 2 squared, so 2 times 2, which is 4. We are then going to be taking away 2 times by 2, so we're going to be taking away 4. So in here we've got 0. And on the last space we've got 3 squared, so 3 times 3, which is 9. We're going to be taking away 2 times by 3, which is 6. So in this last part of the table we should have the value 3. We then just need to plot the coordinates that we've just generated. So we've got minus 1, 3. 0, 0. 1 minus 1. 2, 0. And 3, 3. AQA are getting a lot harsher on the drawing of graphs this year, so I'm going to apologise at this point that my graph might not be the best representation. Obviously you're going to do this in pencil, but we'll just join these points up with one smooth curve. The last part of question 10 is writing down the coordinates of the turning point on the graph. So here we're just looking at where the graph changes direction. So that's this area here. So the turning point for this question is at 1 minus 1, making sure that we get the x and the y part of the coordinate the correct way round. Question 11 is looking at error intervals. It tells you in the question that each length or each side length of a quadrilateral is measured to 1 decimal place. So that means that our error interval, we've got to look at whether this 2 here, what's the smallest that could be for the 5.2. So the smallest it could be is 5.15. The largest that it could go up to is 5.25. The error interval for the perimeter, well, it's a quadrilateral, which means that it's got 4 sides. So we're going to be doing 5.15 times by 4, which is 20.6. So that's the smallest that it could be. And we're going to be doing 5.25 times by 4, which is 21. So we've got an error interval for the perimeter of 20.6 centimetres to 21 centimetres. Question 12 is a solving an equation. Now the common mistake here is doing the wrong thing first. So if I look at this question, because it's got a divide, everything is divided by 6, the first thing that I actually need to do is to multiply both sides by 6. So I'm going to multiply both sides by 6 first. So this then gives me 2w minus 3 equals 24. From here, I now need to add 3 to both sides. So I get 2w equals 27. Now divide 27 by 2 to get w equals 13.5. Now don't be scared of getting a decimal answer here. It is quite common in the higher paper to get decimal or fraction answers. The second part to question 12 is solving an inequality. Now we met these slightly earlier on. This one is slightly more difficult, but not much. So the first thing that we're going to do is add 25 to both sides of our inequality. So we get 4x squared is less than 25. We can then divide both sides by 4. So we get x squared is less than 25 over 4. We then need to square root to get rid of the x squared. So we get x is less than the square root of 25 over 4. Now we've got to remember that this is plus or minus because we've taken a square root. So we get from this point then that x is less than plus or minus square root of 25 is 5 and the square root of 4 is 2. Now because we've got plus or minus, what this actually means, I'm going to leave this as a fraction. We've got minus 5 over 2 is less than x, which is less than 5 over 2. You could turn this into a decimal, either would be acceptable. So it could be minus 2.5 is less than x, which is less than 2.5. When it's got an inequality, it can be quite difficult trying to think how to write our answer. But if you've got a plus or minus, we need to turn it into an inequality that looks like this. Question 12 part C is another solving an equation. This time we're going to multiply both sides by y minus 6. Let's try and get rid of that fraction. So we get 1 equals 5 bracket y minus 6 because we're multiplying the 5 by all of y minus 6. I'm going to expand this bracket now to get 1 equals 5y minus 30. So that means once I add 30 to both sides, I get 31 equals 5y. If I then divide 31 by 5, I get y equals 31 over 5. Now, as I've said in a previous question, don't be scared if you are left with a fraction at the end. Just double check your working. It's perfectly fine to leave your answer as a fraction rather than trying to change it into a decimal. If you wanted to change it into a decimal, you could if you really wanted to, but I tend to say to people, leave it as a fraction so you're not making mistakes. In this case, 31 divided by 5 would be 6.2. Either of these answers, again, are acceptable. Question 13a, again, is actually just checking that you know the values, your trig values of sine and cos. If you actually flick back to question 1, I do list all of these out. So the value of cos 60 is a half. Question 13b is your first real test to see whether you've learnt your formulas. So here we've got a non-right angled triangle and it's trying to find a side length with an angle that's in between two sides. Now that means that we're going to be using the cosine rule. So that is b squared equals, in this case, 5 squared plus 8 squared minus 2 times 5 times 8 times by cos 60. Now in the previous question we did find out that cos 60 is a half, so I'm just going to replace that with a half. And then we can just go ahead and work all this out. So we've got b squared equals 25 plus 64. Take away 2 times 5, which is 10, times by 8, so 80, times by a half, which is 40. Carrying on, 25 plus 64 is 89, take away 40 is 49, so b squared equals 49, which means b equals 7. As it is a side length, obviously we can't have a negative side length, so we're only looking for the positive square root of 49. Question 17 is having a look at indice laws. 8 to the power minus 2 means that with the minus in the power that we are going to be having 1 over, and then it's just 8 to the power 2 because of that little 2. So that means we've got 1 over 8 squared, which is 1 over 64. 17b is just checking your understanding of index laws. So we've got 4 to the power x equals 8 to the power 2 over 3. So let's work out what 8 to the power 2 over 3 actually means. So because it's a power that's over 3, that means that we're finding the cube root of 8, and because there's 2 on the top, that means that we're squaring it. So we've got the cube root of 64, which is 4. So we've got 4 to the power x equals 4, so x must be 1. Question 17c is having a look at index laws and surds combined. So we just need to work these out. So we've got the square root of 3 to the power 0. So anything to the power 0 is 1. And we're multiplying that by 3 to the power 1, which is 3, plus 3 squared, which is 9. So we've got the square root of 1 times by 12, which is just the square root of 12. Now when we're looking at simplifying a surd, we're looking for a square number that will go into 12 in this case. So we can write this back out as the square root of 4 times by 3, with 4 being our square number, which means that this is the same as the square root of 4 times by the square root of 3. And the square root of 4 is 2, multiplied by the square root of 3 is just 2 root 3. As you can see, once the answer in the form a root 3, where 2 is our a, and we've got the root 3 that we need. Question 18 is looking at a velocity time graph, and it's wanting us to estimate the distance travelled in the first 10 seconds. So when we're trying to estimate distance from a velocity time graph, we're looking at the area under the graph. So in this case, we're looking for the area that is underneath the graph from 0 to 10 seconds. Now how we're going to do that, we're going to break that into a triangle, and we're going to find the area of this triangle. So we've got a base of 10, and if we read the value across on our graph, we've got a height of 44. So to find the area of this triangle, we are going to do 10 times by 44 and then half our answer. So we've got 44 times by 10 and half our answer. So we've got 440 over 2, which is 220. In the question it does give you the units, so we don't have to worry about that. So we've just got 220 metres. Question 19 is having a look at the area of a triangle and a trapezium. Now this triangle is a non-right angle triangle, so we're going to be using the formula a half AB sine C, where 6x is A, 8y is B, and sine of the angle, so sine C, is a third, it tells us here in the question. So the area for that triangle then, we've got half times by 6x times by 8y times by a third. Some quick sort of mental calculation, you might want to write it down in full, but we know that that is 8xy. The area of the trapezium, we add together the parallel sides, so that's the 10x and the 4x. So we've got 14x, we half that and times it by the height, which is 3x. Again, some quick calculation in here, this works out at 21x squared. It does tell us in the question that these are equal to each other. So we can go ahead and set those equal to each other now. So we get 8xy equals 21x squared. And then it tells us to give our answer in the form y equals a over b x, where a and b are integers. So we just need to rearrange this. So if we divide by 8x on both sides, we get y equals 21x squared over 8x, which can then be simplified to y equals 21 over 8x, and that's our answer. Question 22 is having a look at composite functions. So we're told that f of x equals 2x squared and g of x equals x plus 5. And it's wanting the composite function f of g of x. Now this means that we start with g of x and we sub that into f of x. So we have g of x is x plus 5, and we need to sub that wherever it says x in the f of x function. So we have 2 times by x plus 5 squared, which is this one here. Question 23 looks a tricky question on the surface, but it's actually just checking the use of Pythagoras theorem and surds. So I'm going to go straight ahead and find the missing side on the right angle triangle at the top using Pythagoras theorem. So in Pythagoras theorem we can work out the missing side as it's 6 squared take away 4 squared, and we want the square root of that. So 6 squared is 36, we're taking away 16. And we still want the square root, so that is square root of 20. Now I'm going to go ahead and simplify this while we're looking at it. If you're struggling with simplifying surds, you do need to take a look, because it will turn up on your exams this summer. So root 20 is the same as root 4 times by root 5, which is just 2 root 5. So to find the area of the shaded square, what I'm going to do is find the area of the large square, the white bits, and then I'm going to take away each individual triangle. So the sides of my square are 6 and 6, which means that that area is 36 centimetres squared. The area of my triangle, now that I know the base, which is 2 root 5, is 2 root 5 times by the height, which is 4, and halved. So that means I get 4 root 5. Okay, and there are 4 of those that I need to subtract. So I need to multiply this by 4. So 4 root 5 times by 4 is 16 root 5. The area for the shaded part then is 36, the area for the larger square, and we're taking away the area of the triangles, which is 16 root 5 centimetres squared. That's the end of this walkthrough. I hope it's helped. Good luck with your exams in the summer. Keep revising and you'll do well.